Acha, so I have shared my whiteboard again, and I guess that you guys are able to see it. Okay, let's talk about the very first topic. That is a very, very basic topic. We'll just spend a minute or so on it, and then we'll talk about the next one. Sabse pehle, we need to understand the difference in vectors and scalars. It is easy, it's not difficult, okay? सबसे पहले I'll write down the definition of vectors. Vector has magnitude plus direction, and scalar has magnitude only. For example, if I give you some examples on this side, so let's say there's a person who's walking on a path and he is going towards the right side. So he has traveled, let's say, 1 kilometer towards the right side. Okay. Now, if you ask that person how much distance you have covered, he would say 1 kilometer. He did not talk about the direction. But if he says that I walked in the right direction for 1 kilometer, that would also include the direction. So in mechanics, we have most of the quantities as vectors as well, right? For example, if I talk about some of the examples, let's say distance, okay? Distance is just the magnitude without direction, and displacement is magnitude plus direction. Okay, I'll explain these, don't worry. Then the second type is speed. We are used to talking about speed, but if we talk about the direction as well, that would be velocity. Other than this, if I talk about the mass, it is actually the weight and then we have length slash height, etc., etc. Okay, now I am not talking about all the vectors and all the scalars that we will be talking about in mechanics. No, I just want to give a basic idea about the difference in these two. So let's say that there's a person who's traveling in this direction and his speed is 3 meters per second. Okay, now since he is traveling in the left direction, if we want to specify the direction, we would have to use the sign. Okay, so let's say I am using positive for the right side and negative for the left side. So positive 1 kilometer means that the person is going to the right direction, and negative 3 meter per second would mean that the car or the person is going in the left direction. In short, the difference in scalar and vector is of a sign. When we add positive and negative to that, that does not make it that does not make the value less or more. ठीक है, उससे सिर्फ ये होता है कि आपकी क्वांटिटी में डायरेक्शन ऐड हो जाती है, एंड वो डायरेक्शन आपके ऊपर डिपेंड करती है. अगर आपने पॉजिटिव साइन देना है राइट साइड के लिए तो यू कैन यूज पॉजिटिव. अगर आपने नेगेटिव साइन देना है राइट साइड के लिए, इट इज कंप्लीटली योर चॉइस. आंसर्स कभी भी गलत नहीं आते. लेट्स से दिस टाइम अराउंड मैं राइट साइड के लिए नेगेटिव दे रही हूँ और मैं लेफ्ट साइड के लिए पॉजिटिव दे रही हूँ, तो -1 किलोमीटर का मतलब होगा कि वो राइट साइड पे जा रहा है, और पॉजिटिव 3 मीटर पर सेकंड का मतलब होगा कि वो लेफ्ट साइड पे जा रहा है. एवरीथिंग डिपेंड्स ऑन दिस चॉइस, जो कि मैं अपने हिसाब से कर सकती हूँ. ठीक है, एंड अभी हमने हॉरिजॉन्टल मोशन की बात की, हम सेम कॉन्सेप्ट यूज कर सकते हैं फॉर वर्टिकल एज वेल. तो I will give you the scenario and I would want you guys to tell me the sign. Okay, so let's say For the upward direction, I am using positive, and for the downward direction, I am using negative. ठीक है? अच्छा. And let's say this is a stone that is coming the downward direction with the velocity 8 meters per second. This is the first example. Second one could be that this is the horizontal surface and this is a stone. तो हमने ऊपर फेंका है, इसने distance इतना कवर किया. ठीक है? That is basically, let's say 12 meters. Okay. My question is that how should I write down this speed such that it becomes the velocity? Yes, Zohan?
मैम डायरेक्शन बता देंगे -8 मीटर पर सेकंड.
Very good. ठीक है? Because in questions and for answering the examiner, we are not going to use this. We are going to use this. Okay. And what about the second one? So basically, this was the stone. इसको हमने ऊपर की तरफ फेंका है, इसने 12 meters का distance cover किया है. What would be this distance as a vector? It would be displacement. And how are we going to define the direction? This direction? Yes, Subhan?
Ma'am, with the positive sign.
Very good. And why with positive sign? Because this is how I have defined it. Let's say मैं यहाँ पे कुछ और यूज कर लेती हूँ. Negative for the upward direction and positive for the downward direction. Now things would be different. Downward direction is positive. If the stone is coming downwards, तो मैं यहाँ पे positive rate use करूँगी. And if the stone in the second example is going in the upwards direction, तो मैं -12 meters use करूँगी, right? Because that would be the displacement. Okay. So this is the only thing which we need to understand. Most of the times, right side के लिए we will be using positive direction, and upward के लिए we will be using positive, and then downward के लिए negative, and then left के लिए negative. But that is just for our convenience. This is just how we are used to doing it. ठीक है? Otherwise भी करेंगे तो वो भी आपको आंसर ठीक देगा, right? So any doubts about it? We are done with vectors and scalars. I did not talk about every example since we had a similar discussion in the demo class as well. So I wanted to talk about this in the very beginning.
मैम ये जरा मुझे बताइएगा, ये यहाँ पे मतलब कि वो वेलोसिटी जो है वो मतलब कि पॉजिटिव 8 मीटर पर सेकंड होगी, लेकिन मैम वो डिस्टेंस जो कवर हुआ है वो -12 मीटर क्यों है?
क्योंकि एक तो बात ये है कि वो जो एग्जाम्पल 1 है वो एक सेपरेट एग्जाम्पल है, एग्जाम्पल 2 एक सेपरेट एग्जाम्पल है. ठीक है? एग्जाम्पल 2 में ये जो ग्रीन स्टोन है, इट इज गोइंग इन द अपवर्ड डायरेक्शन, एंड मैंने सिर्फ इस एग्जाम्पल के लिए ऊपर बताया हुआ है कि अपवर्ड डायरेक्शन के लिए वी आर यूजिंग नेगेटिव. व्हाट इफ आई डिफाइन द अपवर्ड डायरेक्शन विद अ नेगेटिव साइन? -12 का मतलब ये होगा कि स्टोन 12 मीटर्स अपवर्ड डायरेक्शन में गया था. ठीक है? दिस इज व्हाई इट इज लाइक दैट. ये दोनों एग्जाम्पल सेपरेट एग्जाम्पल्स, इनका आपस में कोई लिंक नहीं है.
ठीक है मैम. ओके
ओके, वेरी गुड. नाउ लेट्स टॉक अबाउट topic number 2, that is one-dimensional motion, and we'll talk about the horizontal one. So we are basically talking about one-dimensional motion, and for now we are just going to talk about the horizontal motion. Okay. Now we will talk about some of the contents through which we will be calculating, let's say, the velocity, the displacement, the acceleration, time, that totally depends. Okay. Now in this section, you'll see the examiner might give you a scenario where there's a car, there's a person, a train, a plane, no, not a plane, because we are talking about the horizontal motion, but anything that is traveling in the horizontal motion, right? So the examiner would give you some of the things. Let's say he would give you the time, the direction, or the distance, or the displacement, and the velocity, and he would want you to calculate the acceleration. Okay, so he would give you some things and he would ask you and he would expect you to find a few things, and we will do that with the help of some equations. So let's write down those equations first, and then you'll see how to use them. Okay, so let's get started. Right.
सॉरी मैम वो मेरी ब्लैक स्क्रीन आ गई थी बिल्कुल मुझे नजर नहीं आ रहा.
All right. Okay. Equations for constant acceleration. Okay. I'll write down the equations first and then I'll explain the concept. Okay, don't worry.
मैम कांस्टेंट मीन मतलब चेंज नहीं हो रही, एक ही स्पीड में चल जा रहा है.
Exactly. And this is the most important thing. इसके अलावा हम कर ही नहीं सकते ये वाले. I'll write down some of them first. V equals U plus AT. Then we have S equals UT plus half AT square. Then we have V square equals U square plus 2AS. And then we have two more, which we can derive using these three, but obviously we don't have that much time. So it's good that we have these two equations as well. This one is S equals VT minus half AT square. And then this one is S equals half Q plus V into T. Okay. This one is the first one, the second one, the third one, the fourth one, and the fifth one. Most of the times we will be using 1, 2, and 3 only, but there would be times where we can use 4 and 5 just for our convenience, right? Okay. Now let me just quickly write down what is V and what is U and all that, and then I'll explain it to you. So V is the final velocity, U is the initial velocity, A is the acceleration, T is time, S is displacement. Okay. Now, for now, we did not talk about how do we define velocity, how do we define displacement, time, acceleration, and stuff like that, right? But we have been studying maths and we know how to use equations and how to use formulas, right? Okay. Basically, let's talk about the first three equations. These are your go-to equations whenever you have one-dimensional motion. It could be the horizontal one, it could be the vertical one. We did a few past paper questions for the vertical one in the demo class, okay? So when we say one-dimensional, it could be either vertical or horizontal. It totally depends, okay? Now we'll see the question types after this one. Like I'll switch to the PDF that I'm going to cover today for the past paper questions. And you are going to see that in all those questions, the examiner is giving you a few things. You need to understand the scenario and then use these equations. For now, I just want you to understand that v is the final velocity. So if you have a scenario, it could be that your scenario is basically made up of two scenarios, right? So let's say I am going to talk about the horizontal motion for this one. Let's say we have a ball, okay, and it is traveling in the right direction with some initial velocity u. And then let's say this point is A, this point is B, and then this point is C. The velocity of the ball at C would be V, I agree, because that is the final velocity. But it could be that for some time we think about A and B as the only positions, and we think about the velocity of the ball at B as V, right? So if you remember, we did a past paper question in the demo class, and there I used the same assumption, right? Are you guys able to understand this?
Yes, ma'am.
So final velocity does not mean कि ये velocity सिर्फ end point पे होगी. Your end point could be any point. It could be B as well. It could be C as well, right? We can use small scenarios in order to find the acceleration at this point, in order to find the time taken for the ball to travel from A to B. It totally depends on the question, right? Okay. Acceleration is just the quantity. When your acceleration is increasing, your velocity is increasing. Keep understand it this way. Acceleration is basically velocity over time. I'll talk about that, but later. For now, just think about it as a quantity. Time is time, that's simple. And displacement is the distance with direction. Now, you must be noticing that in all these equations, we have velocity, velocity, displacement, velocity, 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 then displacement, acceleration is also a vector quantity, and we do not talk about the scalar version of acceleration. So yeah, the idea is that other than time, all the quantities in these equations are vector quantities. So we need to be extremely careful while writing down the sign. Okay, so you'll see the past paper questions that I'm going to do now. I am going to assign positive and negative for the directions, and then I am going to talk about the question, because in these statements, the examiner is not going to tell you negative 3 meter per second or positive 3 meter per second. He is just going to tell you that a ball is moving horizontally with 3 meter per second to the right direction or to the left direction. And that is how you need to understand that how to put the sign next to it. Okay. So anything that you have not understood so far?
No, ma'am.
All right. So now I am going to stop sharing this and I will share the questions with you. I've shared the questions. Are you guys able to see it? Let me do the second one or the
Yes,
first
ma'am.
one first. Yeah, okay. Now this is the first question. Okay, it's a past paper question. Let's understand it and then we'll do it. Okay.
मैम ये पेपर कितने मार्क्स का होता है?
अभी फिलहाल तो I've just picked up 2 questions, and उन 2 questions में से this one is for 4 marks and ऊपर वाला question that's for 6 marks, but that depends. Okay, different variants for different both. So we'll come to that later when we do past paper questions. Okay.
Okay, ma'am.
Right now the वैसे mostly it is for 50 marks, but honestly speaking it depends. Okay, variants different होते हैं, then we have different boards as well, so I'm not really sure about this, but मैंने भी Cambridge का ही दिया था तो मेरा 50 marks का था. I remember that. Okay, but we'll look into that later on. Okay, do not worry about that.
मैम
Okay,
आपने कितने साल पहले दिया था?
मैंने दिया था 5 years पहले.
लाइक अभी अब यूनिवर्सिटी से खत्म हुआ आपका भी?
Yes,
fresh.
last year.
ओके, सही है, सही है.
Okay. Question क्या है? a car travels along a straight horizontal road. Okay. Abhi tak we have just discussed one dimensional motion. So इसीलिए we obviously have this assumption in our minds कि वो one dimensional होगा, but exam में ऐसे नहीं होगा, ठीक है? So this is a key word कि ये one dimensional motion है. You will not worry about anything other than the signs, okay? You'll see कि बाकी 2D motions में we need to talk about the angles as well, but for now we are good to go. This is just a one dimensional motion and we have it in the horizontal direction. Okay. So instantly, I am going to use the signs. For the right side, I will use positive, and for the left side, I am going to use negative. Okay, now I'll read it. So a car travels along a straight horizontal road. When it passes a set of traffic lights, it is traveling at a speed of 3 meters per second. Okay, so let's make the diagram. This is the road. And we have a car. Let's say of this type, okay. And when it is passing a set of traffic lights, let's say these are the traffic lights. इस point पे उसकी speed है 3 meters per second. अभी के लिए we'll not talk about the final, the initial, no. अभी के लिए we'll just make the diagram whatever way the question is given. The car then accelerates at a constant 1.2 meter per second square until it reaches a speed of 9 meter per second. Okay. So we have the acceleration. Accelerate after it passes the traffic signal. So the acceleration after this point is 1.2
Final velocity 9 होगी
per second square, yes. And there's a point, and this point पे उसकी velocity 9 होगी है. Show that the car accelerates for 5 seconds. Okay, we will show that, but first let's just be sure about the signs, okay? Now everything is happening in the positive direction. They did not talk about the brakes. They did not say that the speed reduced, stuff like that. So this means that all this is happening in one direction. Yes, they did not talk about the right direction or the left direction, but this is an assumption. This is how we start the question. This is how we think about it. We will assume that the car is going in the right direction. Then we have a traffic signal. You can also think about the same scenario other way around as well, that the car is traveling in the left direction, but let's not complicate things, okay? So you will see this would be my standard practice. This is how I'll be starting the question. I'll be making the let's say the particle, the car, the animal, the bus, whatever it is, at the very beginning of the left side, and then I'll make it move in the right direction. Okay, right. Now this is an easy question. We do not have any stuff about the opposite direction. Okay, so let me just write down what exactly we have. We have u, that is the initial velocity. And what is the initial velocity? Initial velocity is the velocity in the beginning of the scenario, that is 3 meter per second. What is v? V is the final velocity, and that is 9 meter per second. And what is acceleration? Acceleration is 1.2 meter per second square, right? So we have these three things, and we need to find the time. What time exactly? The time which the car is taking from traveling from this point to this point, right? From 3 meter per second to 9 meter per second using this acceleration. So how are we going to find this time? We have the very first equation, that was v equals u plus a t. V is 9, u is 3, and then acceleration is 1.2, and I need to calculate the time. So I'll write it down as it is. Then it would be 9 minus 3 equals 1.2 t, that is 6 divided by 1.2 equals t, and that is going to be, you can just calculate it and you will find it to be 5 seconds. And this is what we had to show that the car accelerates for 5 seconds, right? So did you understand this question, both
Yes,
of
ma'am.
you?
मैम आप इसकी डिफिकल्टी को कितना रेट करेंगी?
This was an easy question.
Like ये actually पास पेपर्स में आ गया.
Now a past paper question, obviously.
Okay, सही है.
Right? Okay. The second question says, find the distance that the car travels as it accelerates from 3 meter per second to 9 meter per second. Okay, now initially we were calculating the time taken. Now we need to calculate the distance. Okay, so I want you guys to use the equations that we have discussed and calculate the distance that the car would travel from 3 meter per second to 9 meter per second. If this point is A and if this point is B, let's calculate the distance between these 2 points A and B, okay?
मैम फॉर्मूला अगर आप लिखते हैं.
We have so many formulas, वही तो आपका decision होगा.
मैम वो स्लाइड दिखा सकती है, मैं फोन पे तस्वीर ले लूंगा, देन मुश्किल नहीं होगी.
Okay. Are you done with the screenshot?
Yes, ma'am. Thank you.
You're welcome.
Ma'am, 30 है answer.
And who is this? Subhan or Zuhan?
Ma'am, Zohan.
Okay, and what about you, Zuhan?
Ma'am, Zohan.
So what
No,
about
ma'am,
you?
मैंने आंसर बताया.
जिसने नहीं बताया वो बता दे प्लीज. दोनों में से किसने नहीं बताया?
मैम वो स्क्रीनशॉट असल में नहीं था ले गया, लेकिन मैं कर लूंगा, मुझे इक्वेशन का बस पता चल जाए, मैं कर लूंगा ये सॉल्व.
Achha, okay, so basically you will be using v square equals u square plus 2as. Like you can use this equation and you can use some other equation as well. So for now, let's just do it with this, okay? Plus 2as. You have v, you have u, you have a. You need to find s, okay? So it's good that you use this one. Obviously, this time around, we are sure about the time as well, that is 5. But let's say the first part was just to find time. In that case, I would strongly advise you to use this equation. Do not use वो equation जिसमें time हो, because you are not sure about time, right? Because you have calculated that on your own. ठीक है, इस example में तो the question was show that the car accelerates for 5 seconds. But what if the examiner just wanted you to find the time and you had calculated it on your own, तो उस केस में I would not advise you to use any of the equations including time जिससे आपने displacement find करनी हो. Is this okay? Both of you?
Yes,
Yes,
ma'am.
ma'am.
Okay.
मैम पर मैंने सेकंड इक्वेशन यूज की थी.
ठीक है, that's okay. That's okay. All right, let's talk about the next question now. Okay. It says a particle P moves in a straight line across a horizontal surface with retardation of magnitude 1.8 meters per second square.
मैम ये रिटार्डेशन क्या है?
Retardation is just the acceleration but in opposite direction. Retardation का मतलब है कि उसकी स्पीड रिड्यूस हो रही है, एंड उसका
तो
मतलब ये है
साइन
कि
नेगेटिव है उसका.
अगर वो अगर वो पार्टिकल राइट साइड पे मूव कर रहा है और अगर वो रिटार्डेशन कह रहे हैं, इसका मतलब एक्सेलरेशन लेफ्ट साइड पे होगी, उसको कोई चीज लेफ्ट साइड पे पुल कर रही होगी. इट कुड बी द फ्रिक्शन एज वेल, या कुछ भी हो सकता है, बट वी डोंट नो दैट. ओके, सो लेट्स नॉट गेट टू दोस डिटेल्स. ओके, द
Okay, so
पार्टिकल
retardation is actually acceleration का opposite.
एग्जैक्टली एक्सेलरेशन का ऑपोजिट नहीं, इट इज एक्सेलरेशन इन ऑपोजिट डायरेक्शन. ठीक है, डायरेक्शन ऑपोजिट होगी. यू कैन थिंक अबाउट इट दैट वे. एंड या दिस वे एज वेल,
Okay,
एक्सेलरेशन का ऑपोजिट, एक्सेलरेशन स्पीड इंक्रीज करता है, रिटार्डेशन स्पीड डिक्रीज करता है. यस, दैट इज दैट.
अगर रिटार्डेशन दिया हो और हमने एक्सेलरेशन निकालनी हो तो हम सिर्फ नेगेटिव साइन हटा के पॉजिटिव लगा देंगे.
नहीं, दैट डिपेंड्स. जरूरी नहीं है कि रिटार्डेशन के लिए आप साइन चेंज करोगे. इट डिपेंड्स. ठीक है, ऑब्वियसली एक्सेलरेशन ज्यादा कम हो सकती है, रिटार्डेशन ज्यादा कम हो सकती है. फॉर दिस सिनेरियो दे आर टेलिंग अस कि एक पार्टिकल है जो कि स्ट्रेट हॉरिजॉन्टल लाइन पे मूव कर रहा है, ये वन डायरेक्शनल है. रिटार्डेशन का मतलब है कि इस केस में जो एक्सेलरेशन होगी वो -1.8 मीटर्स पर सेकेंड स्क्वायर होगी. दैट इज इट. और वो माइनस क्यों है? क्योंकि जैसे मैंने पहले बताया था, राइट साइड के लिए वी विल यूज पॉजिटिव डायरेक्शन एंड लेफ्ट साइड के लिए वी विल यूज नेगेटिव डायरेक्शन. ठीक है, इज दिस ओके नाउ?
Yes, ma'am. Okay.
Right? Do not get confused with retardation. Retardation के लिए just remember that ये speed reduce कर रहा होगा. तो अगर आपका particle right direction में move कर रहा है and they have used the word retardation, it means acceleration जो होगी वो opposite direction में होगी, वो left direction में होगी. तो left direction के लिए हम negative use कर रहे हैं. ठीक है? Okay. The particle passes through a point A with velocity 5 meters per second as shown in the diagram. It subsequently passes twice through the point B where AB is 2.5 meters. अभी के लिए इस बात को let's keep on hold and then we'll talk about it later. Okay. Find the velocities of P on the two occasions when it passes through B. Okay. And then the second part says, find the length of time between the two occasions when P passes through B. Now, what exactly are these two occasions? They are trying to tell us कि ये जो particle है, ये B point के ऊपर 2 बार गुजरेगा. Now, you need to understand the concept very, very carefully. ठीक है? ये particle है and इसकी एक initial velocity है 5 meters per second की. ये वेलोसिटी कांस्टेंट नहीं है, ये इनिशियल वेलोसिटी है जिससे आपने उस पार्टिकल को पुश किया. उसके बाद एक कांस्टेंट रिटार्डेशन है या कांस्टेंट एक्सेलरेशन है ऑपोजिट डायरेक्शन में, जो कि उस पार्टिकल की स्पीड को स्लो कर रही है. ठीक है, तो ये पार्टिकल मूव कर रहा है, कुछ पॉइंट बाद इसकी स्पीड 4 होगी, उसकी स्पीड 3 होगी, उसकी स्पीड 2 होगी. मैं ये रैंडम वैल्यूज लिख रही हूँ, ये बी पे 2 नहीं होगी, मैं वैसे बता रही हूँ. फिर 1 होगी और फिर 0 होगी. जब उसकी स्पीड 0 होगी तो वो लेट्स से यहाँ आ जाएगा. ठीक है, उसके बाद ये जो रिटार्डेशन है या ये जो एक्सेलरेशन है, इट इज स्टिल देयर. एक रुकी हुई चीज को अगर आप लेफ्ट साइड पे पुल करेंगे तो आपका जो पार्टिकल है अब वो इस डायरेक्शन में मूव करना शुरू हो गया है. तो अब उसकी स्पीड आहिस्ता आहिस्ता बढ़ी है एंड नाउ इट इज मूविंग इन दी लेफ्ट डायरेक्शन. तो बेसिकली एक ये पॉइंट होगा जब उसकी स्पीड कम हो रही होगी और वो 0 हो जाएगी, और फिर 0 से जब वो लेफ्ट डायरेक्शन में मूव करेगा तो वो दोबारा बी पॉइंट के ऊपर से गुजरेगा. दैट इज व्हाई दे हैव यूज्ड द टर्म 2 occasions, राइट? सिर्फ
Right,
क्वेश्चन समझ में आया?
Yes, ma'am.
ठीक
जी
है,
मैम आ गया.
ठीक है, okay. All right, let's calculate the velocities now. We'll do first part today, then we'll do the second part tomorrow. So let's do it quickly. Okay, ये तो मैंने खुद से लिखे थे 1 4 2 3. Okay. Find the velocities of P on the two occasions when it passes through B. Okay. Now the distance is 2.5 meters. The initial velocity is 5 and the acceleration is minus 1.8. So what equation are we going to use here? Okay. U is 5. Acceleration is minus 1.8. Displacement is 2.5. And we need to find the velocity at point B. So I am going to give it V. Okay, we need to find V. That is the final velocity. Do not think about the final point as this point जहाँ पे उसकी speed 0 होगी. Yes, it could be that point, but उस scenario के लिए, इस scenario में हम अपना displacement 2.5 meters use कर रहे हैं, तो starting point initial velocity का है 2.5 meters के बाद हमारे पास final velocity आएगी, ठीक है? तो we know it would be v square equals u square plus 2as. V square, we need to calculate V. U square would be 5 squared, that is 25, plus 2 into minus 1.8 into 2.5. And now you are going
मैम
to
16 आंसर है. Sorry,
very
8 है.
V square is going to be 16 and V is going to be plus minus 4 meter per second. This plus and minus are basically giving you the velocities. ठीक है, अब हमें ये बात तो समझ में आ गई थी कि पहले पॉइंट पे गुजरते हुए ये ऐसे जा रहा होगा, तो ऑब्वियसली इसकी जो वेलोसिटी होगी वो पॉजिटिव होगी, और जब वो वापस आ रहा होगा तो उसकी वेलोसिटी नेगेटिव होगी, राइट? तो दैट मीन्स के एक वेलोसिटी हमारे पास 4 है और दूसरी वेलोसिटी हमारे पास -4 है, तो इसका मतलब है कि इस पॉइंट पे it would be 4 meters per second and then इस पॉइंट पे it would be -4 meters per second, right? Did you understand the first part?
Yes ma'am, easy.
Yes, ma'am.
All right, I'll stop sharing the screen, I'll stop the recording and